So I was going to talk about human factors tonight, but I realized that we had never actually talked about radio navigation before. And I'm pretty sure that you'll see a question about radio navigation down the road somewhere. Um, Maybe it'll be on, the FAA written exam if you take that, or maybe it'll be on the practical. I don't know. But I thought it'd be worthwhile to go over radio navigation. So that's what I'm going to do tonight. It might not take the whole time, so this might be shorter, but I want to do human factors kind of all in one go. So we'll see what happens. But so first, let me start with what radio navigation is before I get to specifics. So radio navigation is simply that. It is using the radios in the aircraft to find points on the ground that send out radio signals and navigate to those using a variety of methods. So the two main types of radio navigation aids that we'll have are what are called non-directional beacons, and we'll have VORs. Non-directional beacons are being phased out slowly. They'll be gone eventually. VORs are also sort of being phased out, but they're still around. So they'll be around a little bit longer than NDBs. But there's far less NDBs out there than there are VORs. So VORs are still used today, mostly as checkpoints. They're great for cross-referencing and triangulating your position because there's enough of them out there. And they give you precise coordinates, unlike NDBs, which NDBs will just give you a direction to the station. So that's kind of the main difference between the two. We're not going to really talk about NDBs and how to use those very much. I might show you an example, but other than that, we're not going to really talk about NDBs all that much. We're going to mainly focus on VOR, or VORs, plural. So first, let me start out by showing you a picture of a VOR. Open image, new tab. There we go. So this is a VOR. If you go out to the Houghton Airport, you can look out there, and in the middle of the airport, you'll see something that looks similar to this. Might look a little bit different, but it has some sort of cone and it has a circle. And VOR, you don't have to remember this, but VOR stands for very high frequency omnidirectional range. And basically what it is every degree of the compass, so 360 degrees, this VOR sends out a signal. And each degree, or as we'll refer to them now, radial, is assigned a specific radio frequency or a specific band to operate on. And so by taking a sample of bands, specifically on a Cessna, there are two antennas, one on the left and one on the right. You can distinguish what radial you're on. Not only can you distinguish what radial you're on, you can also distinguish what direction you're going. So you're either going to the station or you're coming from the station. Some VORs also have what is called DME capability, and DME stands for distance measuring equipment. So the VOR can tell you how far away you are from the center of the VOR. So these are all kind of nice. There also are other types of VORs. So there's like VORs, just the normal variety of the TACANs, VOR plus DME. And so there's a few different variants, but mostly all look like this, at least physically, and they all do the same thing, mostly. So that's just, I wanted to show you a picture to put a name to a face. But now we're going to kind of talk about how to use a VOR, because we don't really care what they look like. So let me do this. This is just a VOR simulator. Instead of booting up my flight simulator and showing you that, I thought this would be a little bit easier. So I'm going to just create a VOR station here where, let's see, it's Quebec, Juliet, Lima. And I'm just going to put it out here somewhere. So our airplane is right here. I'm going to put him down here. And in order to use a radio navigation aid, we have to first tune into it. So on a sectional chart, the actual image for the VOR will look something like this. This is a VOR with DME, so it has a box around it. But I think when we talked about sectional charts, I showed you the different types of VORs that are out there. And next to the VOR, it'll have a box that tells you what frequency it operates on. And so in this case, the frequency is 110.2. And to tune in, we'll just dial in 110.2 into our radio nav, which is a specific column in our radio stack. And this is separate from our comms. So on a radio stack, you'll have COM1, COM2, NAV1, NAV2, usually if you have two antennas. And so you'll tune this into the standby position, and then you'll swap them over so that you're now navigating towards that radio navigation aid. So as we can see here, we have the frequency in our active slot. We have now the DME showing up on our DME equipment. And so it tells us that we are 30.9 nautical miles from the station. And as we see, if we move closer, it gets really small, and then you get to 0 and you're right over top of it. So that's kind of nice, but not every VOR has that. So so now I think it'd be helpful if I showed you this. So let me tune this. So this is going to be our compass. This is our heading indicator, which is our gyroscopic compass in the aircraft. And right now we are headed north. And these are just our helper lines here. And this is our heading, and then this is our course to the VOR. And so what we're going to do is I'm just going to kind of show you how to operate the VOR equipment in the aircraft, and then I'll show you what a sample question might look like on the FAA exam. So this is the VOR, or the VOR indicator, or the radio navigation device. Sometimes this will also be put with an ILS device, so it might have a crossbar, so it might have another bar that goes horizontally across here as well to indicate glide slope, but this one does not. This one is just for navigating to VORs, but the same principle applies when you're tuning into a localizer at an airport to fly the ILS, but we're not going to worry about that. So so on the VOR device here, we have all of our degrees, so 0 through 360, and this is independent of our compass heading. So if I change our compass heading here, as you can see, we keep spinning around and around and around and around, and our VOR does not change. So this is a fixed card, and in order to move it, we have to move what's called the OBS knob, and it's labeled OBS. And so if I spin this knob, you can see that our lines move, but that doesn't really matter quite yet. And I can select whatever heading I want. The other thing you'll notice is I have this bar. And this bar is what's going to indicate our radial. So whatever line is coming out of our VOR station. And the idea is that if this bar is straight up and down, so like this, we are on the radial and we're tracking directly to the station. But that might not be quite true. There might be a case where we are on that radial, but we're not tracking to the station. Let's say, for instance, we were over on this side. As we can see, we are still on that radial line, but we are no longer going towards the station. We're going away from it. And that's where this to from flag comes in. So the to from flag will tell you whether or not you're going towards the station or away from the station. So as you can see here, we are tracking away from the station. And so we have a from flag. It's a little triangle and it points to from. And vice versa, if we are tracking towards the station, then it'll give us a 2 flag. And so we can use that to kind of get us oriented as to which way the station is away from us. So that'll come in handy a little bit later. So let's say again, we were over here and we wanted to track to the station. So we didn't know, anything about the radial lines or anything like that. We knew that there are 360 degrees of radials coming off the station, and we want to figure out what radial would get us directly to the station if we were to turn right now. So we're tuned in, and we can go over to our OBS knob and we can turn this until we center this line. So keep spinning it and spinning it. Oh, and here we go. So now we've centered that line for the most part. So we know that if we fly this heading, so like a 125 heading, we'll fly directly to the station. But that's not quite true, because we can also see that we have a from flag. And what that means is if we fly 120 or 125 from the station, let's turn a little airplane here, we'll actually be flying directly away. So what we have to do is we either have to fly this reverse course, which means that we go 180 degrees in the other direction. So we tune into something like that. So like a 305 degrees. And we would track that to the station. Or we would tune our VOR 180 degrees and we would track the 2 flag. Now you can do it either way, but this is kind of where VOR navigation gets complicated. If you choose to track the from flag to the VOR station, everything is reversed as far as how you read this device. So I'm not going to worry about that right now. I'll come back to that in a second. Let's just pretend we have the 2 flag. So we're going to go to 305 degrees. There we go. And now we have the 2 flag, and now we can track to the station. So I'm going to turn on these lines again. And this shows us our radial, and then it also shows us the extent to where we can pick up the radial and tell if we're close. Specifically, this is 10 degrees offset. So this line is 10 degrees from this center line. So if you want to think about these dots here, these are all 2-degree increments. So this is 2 degrees off, 4 degrees, 6, 8, so on. So right here we are 10 degrees off, of course. Anything beyond that, we don't get any readings. So we have to be within this window here in order to know our position relative to that radial line. And so we are tracking the 305 radial. And I'm just going to start us moving here. And right now we're right on the line. We're dead center with the needle, and we're tracking right to the station. But what would happen if we started to drift a little bit? Let's say we didn't get our heading quite dialed in, and we thought that we were on the 30 radial. What would happen then? Well, as we can see, our little needle starts to move. In fact, let's give it a little bit more since we're getting kind of close to the station. And so as you can see, our needle moved off to the right. Now, if you think about this needle representing the radial lines coming out of the VOR, this radial that we want to track is now moving off to our right-hand side. And so if we looked out the airplane and could see this imaginary radial, it would be off to our right. Likewise, if we were over here and we drifted to the right of the line, we would see that the line is moved off to our left. And if we looked out our window and saw this imaginary line, it would be off to our left. And so in order to correct for that, we have to turn left to get back on course. And so we have an intercept angle, and we correct and we get back on the line, and then we track it right back down towards the center. Now, as we get closer to the station, something weird is going to happen. Not only will the station get more sensitive, but i.e. the tolerances, so it's going to get really, really hard. So right here, only moving a couple feet can change the degree of that needle quite severely. So if you're navigating IFR without any reference to the ground, and you start trying to follow the needle, it's going to become impossible because it's going to be swinging all over the place. And so what you have to realize is that you're so close to the station that its accuracy is through the roof. And so you really have no way of correcting for these errors that you're going to see here in a second. So as you see, we're starting to drift, even though we're on that radial and heading directly to the station, it's starting to drift away from us. And there'll be no way to correct for that. And pretty soon, it's going to go all the way out, and we're going to switch around. We're going to get a from flag, and then we'll start to regain that needle again once we cross over the VOR. In this region, where our needle kind of just stops working, is what we call the cone of confusion. And so the cone of confusion exists around a VOR in a conical shape going up from the VOR outwards. And so the higher up you are, the bigger this cone is. And so this is something you have to take into consideration when you're flying and using a VOR is how close are you and how high are you? Because you might hit this cone of confusion faster than if you were really low, like 200 feet off the ground and 500 feet away. And so that's just something you have to keep in mind, that these places, these regions exist where the VOR doesn't work very well. And you have to just take that into account. I'm going to stop here real quick. If there are any questions, I will try and answer them. But if not, I will set us up to track the reverse course.
So when you're getting too close to a VOR, it's obviously going to be impossible to track to it. And that means that if your airport, for instance, only has a VOR, you can't reliably land there in IFR conditions.
Right. Yeah. So the VOR is not what allows you to, you can shoot an approach using a VOR, but the actual landing part of the VOR, the actual landing part is not done with the VOR. It is done with what's known as a localizer. And the localizer is on a separate frequency from the VOR. It's a separate navigational aid. And it has very precise and very tuned instruments, which give you a heading and a glide slope. And that information is sent to your airplane over radio. And it tells you exactly, like a VOR, exactly how far you are from the left or the right of the runway. And it also tells you if you're on the glide slope, about 3 degrees usually, how high or how low you are above that. And so that actually is centered on the opposite end of the runway from where you're going to touch down. And so you won't ever hit its cone of confusion. It doesn't really have one. I mean, it does, but it's just set up differently from the VOR. So most of the time VORs are used to start approaches, but usually they're not done to shoot an approach.
They're designed for longer distance navigation.
Yes.
They're
Yes.
obviously not designed to get too close.
Right. Exactly. And there's actually multiple types of VORs. Like beyond the initial scope, there are some that operate at higher elevations, and or they're for higher altitudes, I should say. And so they have different cones of confusion. So that cone of confusion isn't as big, but they don't work down low. They only work up high. And likewise, there's one that work down low, and they don't work well up high. So there's different types, but these are again kind of being phased out because radio navigation is being taken over by GPS, so which is far more accurate. But yeah. So I guess let me run through an example here of tracking the reverse course. And when you're on the reverse course, the thing to keep in mind is that everything is flipped. So when you think you're to the right, you're actually to the left. And when you think you're to the left, you're actually to the right. And so you have to just keep this in mind, and you have to keep this straight in your head, is that when you see, this from flag, everything is flipped around if you're traveling to the VOR. If you're traveling away, then it's the same. Likewise, the to flag could be reversed as well. If you're traveling away from the VOR but tracking to it, if that makes sense. So anyway, let's pretend we are tracking to this station, and we are on we're on the 125 radial, but we're from the station. And so we'll go ahead and start moving here. And let's move to the left of our radial here and see what happens. As we can see, our needle starts to move to the left. Now, if we were tracking to the station, we would correct by moving to the left. But that won't work, because if we move to the left to try and track back to it, we're eventually going to start to move out of the boundary line and we're going to lose it. So that won't work. We actually have to track back to the right in order to recenter. That's pretty easy to see with our little helping lines, but if we didn't have those lines, as you can see, it's very disorienting if you didn't realize that you were tracking from the station, not to the station. So if you're on this radial here, let's see. We started tracking, and then as we got closer, we started seeing it swing away. We might try and correct by going to the left, but that wouldn't work. And eventually we would just do that, and we'd wind up never reaching the station. So the moral of the story is, when you're tracking to the station, everything is oriented correctly, and this line on our indicator represents the radial. When we're tracking to the station with a from flag, this is completely reversed, and we have to imagine that this is instead representing our aircraft, and the line is somewhere invisible on this, let's say in the center. So hopefully that makes sense, and I explained the difference between the two types of tracking well enough to understand. Let me do this real quick. I'm just going to set up some invisible ones. Let's do this one. Okay. So I made them invisible. So now I'm just going to show you how you would track to a station without all those lines and all the helping stuff that this little visualizer gives us. So if we're just flying around and we want to track to some VOR, we'll first tune into the frequency, so 110.4. So I've done that. Now, normally when you're flying, you'll also want to check to make sure the VOR is operational. And the way you do that is you actually have a little button that you can press, and you can listen to the VOR frequencies. So just like a communication frequency, you can listen to these frequencies that the VORs use, and you can, and the VORs actually broadcast a Morse code signal. And that Morse code signal is the Morse code identifier for the station. So in this case, it would broadcast the Morse code of Sierra, and then Papa, and then Sierra. And you would listen for that. And if it had the Morse code, then you know that the VOR station is operable. And if it does not, then you probably shouldn't use the station. So yeah, so we'll listen, we'll make sure that it's the right station, and then it's operable. And then what we can do is we can do one of two things. If we know where the station's at relative to us, we can tune into a specific radial that we want to track, and whenever we fly past that station, we can track and grab that radial. But in this case, we don't know where the station's at, so we're not going to do that. What we're going to do is we're going to spin this dial until we find the radial that centers it with a to flag, because here's our from flag, so we know that we're 180 degrees off. So we need to, I wish this would go faster, but this program did not implement that so nicely. All right, so here we go. So we now know that we are on the 110 radial from the station. So if we want to track to the station, then we'll have to turn 110. And of course, if you're actually flying along, these things would be changing. So you have to take that into account as well. And then we can track like this directly to the station on that radial. And if it starts to move on us, then we can just simply correct. So we see that it's moving a little bit off, and we can keep correcting to keep that in the center. So moving right or left to keep that little needle in the center, tracking right to the station, and we just flew over it. So now I'm going to do this next one while I have the aircraft moving. We'll take this, which is our Gulf Whiskey Echo. We will tune it in to our navigational aid here, our nav radio stack. And then we will go over to our VOR and we'll tune this so that we track to our VOR. And it looks like we're 180 degrees off. There we go. And somewhere in here, perfect. So it looks like if we turn around right here, so it looks like it's off to our left, given the needles out there. So we'll turn up here, see if we intercept it. Let's get a better, let's see here. Oh yeah, we're moving off to the left here. Must be right here. Oh, there we go. So now we're on the radial, so we must have just passed over it. So we were pretty close to that. And as you saw, it got really sensitive. So it got really hard to track because we were so close. And these ones do have DME. I could look at that as well to see how far away. So this one's pretty far away. The other one, we were pretty close to it. So you have that too. But so let's tune this last one here. So we'll tune to the station. Oh, looks like we're pretty far off. All right. So we're not too far here. Might be right on top. Oh, no, maybe not. Oh, yeah, there we go. Okay. So now we're tracking right to it. A little bit off. Probably really, yeah, we're only. Oh, you know what? I think we're actually going the wrong way. There we go. I reversed my compass right there. So now we're tracking to the station. So we're on the 30 radial. Looks like we're a little bit right, of course, or a little bit left, of course. So we're going to turn right. We're still a little bit left, of course. So we're going to turn a little bit more. Give it a little speed boost here. And we're a little bit off to the right, so we'll correct back. And there we go. So we found them all. And as we can see, there they are. So now let's turn these back on. I'm gonna move this little guy out here. So that is pretty much everything you need to know about VOR navigation. Now, obviously, this can go really deep if you start factoring in things like wind, or you start factoring in other things that may prohibit you from getting a signal, um, or whatever. Actually, you know what? I was going to show you one more thing, and that is triangulation. So with VORs, if they're close enough together, you can triangulate your exact position. So if you have a sectional chart that tells you where these VORs are, and you can tune to the radial. So in this case, we are on the 315 radial from Victor, Quebec, India. And then we take this one, this Golf Whiskey Echo VOR, and we tune this one. As you can see, we have triangulated our exact position. We would take this, which is like the 9 radial or whatever, and we would take the other one, which was like the, I don't remember what I said, 135, and we would plot those on a sectional chart, and we would find out our exact position by just extending lines out from those VORs. And so this is pretty helpful for, locating where you're at if you didn't have GPS. So yeah, that's pretty much everything I wanted to talk about with like VOR navigation stuff. I still have one more thing I want to show you, but any questions about VOR radio navigation?
So this is being replaced with GPS. How frequently are these actually utilized in navigation?
So during your training for your private pilot, quite heavily. Once you get to the airlines and the corporate world, they really don't use VORs except for waypoints. GPS is just better at everything. Um, but they do use it. A lot of the like uh, flyways and stuff are based off of VOR radials. So they still track on the same paths, but it's it's just not really something they use anymore. Yeah, just really in the private pilot world.
Shame.
Yeah, and it's beautiful engineering, but yeah, it's archaic. So yeah, let's see. I guess I can show you this. So I am on Exams for Pilots, which I think I've told everyone about this before, but great website for test prep, free test prep. A lot of the test prep out there is not free. And I pulled up one of the questions that would be fairly representative of what you'd see regarding a VOR question. So the question will say something like, the VOR receiver has the indication shown in this case, illustration 1, which I can share this. There we go. So here we have illustration 1. And what we want to know is what exactly our position is relative to the VOR. So there's a few indications that we would look at first. So the first thing is the line is off to our left, and we have a 2 flag. Now, this could mean a couple things. It could mean that we are tracking to the station on a 40 degree, no, a 20 degree heading. So we are to the north and we're tracking to the station on a 20 heading, because that would be 10 degrees off of 30. Or we are off in some other place and like to the south, or something like that. So I think the best way to visualize this kind of problem is to look at the simulator again, and we'll just remember that this is the 3-0 and we're at a 2 flag. So we'll keep that in mind, and we'll go look at this again. So this is the kind of visualization you'll have to do in your head if you get a question like this. So we are going to tune this. Maybe. There we go. And we want to know if we select 0, 3, 0 as our heading in our OBS, what is our position given that this bar is off to the left relative to the station? Now, our heading is kind of irrelevant. Our heading could be anything, and we still get the same indication on our VOR. So for all we know, we could be pointed in any direction. But there are certain cues that we have to take a look at in order to figure out our exact position. And that kind of started us in the position that we're in, but I think I'll move us over here just to take a look. So if we're over here and we're tuned into the 0-3 radial, we're going to be tracking the reverse course of that radial. And so in order to fly to the station from this position, we would actually have to fly a 210 heading because we're off to the northeast. So this would actually be the 210 radial to the station, but because our picture gave us the 030 radial, we're actually on the reverse course of that. So we're going to get a from flag. So we know we're not to the north because we have this from flag. And if that was the case, then yeah, it just isn't right. So so we can't be off to the north or northeast because we get a from flag because that's the reverse course. Because we can't fly a 030 heading. If we tried to fly a 030 heading and we were to the north of the station, we'd be flying away. So that doesn't work. We can't have that. So we have to imagine, where could we be that we'd be flying a 030 heading and we'd be tracking to the station? Well, and the answer is we have to be to the southwest or south-ish of the station. So if we go over here to the southwest and we're tracking the 030 radial, we can see that we're either going to have this radial off to our right, or we're going to be dead center if we're directly southwest. So that's not quite right because in the picture, the radial was off to our left. So we can't be up here. We have to be somewhere over here. And so the answer to this question is that we are to the south of the station. We're somewhere to the right of this 030 radial. So if we select south, then we'll see that we're right. So did that make sense as far as how to solve this? First, you kind of have to imagine where you are, and then kind of your bearing, and then visualize it. But I don't know, maybe there's a different way that would make sense if that didn't make sense.
I figured that the if you have 4 quadrants, then the needle being to the left means you're on the left side, or rather the VOR is to the left of you, and the 2 flag means it's ahead of you, which means that you
Yes.
must be to the uh, southeast of heading 030, which means that you're more or less to the south.
Mm-hmm. Yeah. No,
That's how I
that's
worked that.
yeah. No, that's definitely a perfect way to think about it. If you divide it into quadrants, like these lines are showing here, where you have a dividing line for the to from, and then another dividing line for the radial, then yeah, you can pretty quickly figure out which quadrants you're in, just by deduction. So yeah, no, that's a perfect way to think about it. So yeah, so if you see a question like that, that's exactly how you do it, and yeah, not much to it. The harder thing really is doing this while you're flying the airplane and trying to track these and do reverse courses and stuff in your head and math and like reversing headings and figure out intercept angles and stuff. But that's more of flight training stuff than ground school. But yeah, the other thing is fun. Or the other thing that is fun to do is to just boot up your simulator and just track the Houghton VOR, or go down to Lower Michigan and track some of those VORs down there and try and get your position and just play around with them, because they're kind of fun and they're pretty easy to understand. I don't know, I just kind of find them neat, but yeah, not much to them past that.
It's a lot more involved than just GPS, you are here.
Yeah, I know. Yeah, GPS has made it so easy, and guess that's how it goes. But well, that's all I had for tonight. So looks like we'll get out a little bit early, and then next week we will talk about human factors, hopefully, and we'll get through that. Well, not just human factors, but also aviation physiology. Um, so yeah, so and then hopefully that'll be the last of our topics to talk about, and we'll have gotten through pretty much everything. So